Hi friends, very good evening. How are you all? Hope you are doing fine. How is progress in physics? Per day, how many problems you have been solving? May I know your development? May I know the progress in physics? Hi. Good evening friends who are present today. Message me. Hi Mansi, good evening. Hi Radhika, good evening. Bhuvneshwar, how are you? Josna, Apeksha, Deepak, Indrajit, I am waiting for you all. Hi. So, today let us start the session by looking at the previous question given in the previous debates. Colors appear on a thin soap film and on soap bubbles due to the phenomenon of, majority have written the wrong option. It is due to the thin film interference. Hi Yash, hi Radhika, Bhageshwar, Vyapak. Arey yaar, very new name I have watched. Sir, in which thing should be given greater preference? Greater formulas and concepts are solving problems. All are needed. If you know the concept, if you don't know the formula, you cannot solve. If you know the formula, if you don't know the concept, you cannot solve. Formula and concept are the two sides of a coin. When you know the concept, the next stage is applying the formula and attacking the problem. So, if I ask you which eye is important, left eye or right eye, what do you say? Ours is binocular vision. So, both are important. Like that, both are important. Without formula you cannot solve, without concept you cannot solve. Both are two sides of the coin. Yeah. Now, once again, colors on a thin soap film and on soap bubbles due to the phenomena of, majority have given the option A, which is refraction, but it is not the refraction. It is due to a type of interference called as thin film interference. Thin film interference. This is the answer for the last CPP problem. Now, let us go to the goals of the today's session. A review of diffraction concept. Vinayak Singh, fine. How about you, Vinayak? And let us crack few more examples today, so that you should have complete grip over optics, particularly wave optics, which is very vital for NEET point of view, so that if you solve as many problems, particularly in wave optics, interference is a very hot area, followed by polarization and diffraction. Now, in the last session, I was discussing about the diffraction phenomena, and in that our discussion was Fraunhofer diffraction, single slit Fraunhofer diffraction. In the last session, I had given you key review of the concepts and formulae, and without changing the terminology which I used in interference, the same terminology was applied also to the diffraction. Fine, Vinayak, fine. You are giving a lot of motivation to me, Vinayak. Yeah. So, in the case of the interference, today's session I will give khichdi of problems. Say for example, in NEET paper or in JEE paper, you will not get a same set of questions from the same topic. When you deal with kinematics, the next question may be optics. When you deal with optics, the next question may be AC in the electrostatics followed by electricity. So, your mind have a transit time of very less, nanosecond. It should switch over from one concept to other concept, because our paper in entrance examination is a mix of different lessons and different topics. So, in the Young's double-slit experiment, I used this terminology: D for spacing between the slits, capital D for distance between the center of the slits and screen, delta x for path difference, and yn distance of the nth bright. And these were the symbols I used in the geometry of Young's double-slit experiment, this which I utilized in YDSE. When you come to the diffraction, in YDSE it was a two slit, in diffraction it is a single slit. I used small d for the width of the slit, again capital D for the distance between the screen and the slit, delta x for the path difference, and yn for the distance of the nth bright or nth dark. But one point I told you, the condition for path difference in the constructive interference was delta x is equal to n lambda. This is for CI, constructive interference, and for destructive interference DI, it was 2n plus 1 into lambda by 2. And in the last session I told very clearly, just interchange them, then you will get the condition for darkness, delta x for darkness is equal to n lambda, and delta x for bright fringe 2n plus 1 into lambda by 2. This is the only difference which we observed between the interference by YDSE and diffraction by single slit Fraunhofer diffraction. So, this was a brief recap so that you will be able to handle the problems perfectly. Shall we attack the problems? And in the last session, I discussed the problem related to the position, related to the width of the central bright, related to the angle of diffraction. So, hope you got all the formulae intact. Width of the, what was the last session I have asked, width of the central banks. There I had given a formula for it, followed by angle of diffraction. Now, today's session, the first problem, yellow light. I hope everybody is ready for attacking. Yellow light is used in single slit diffraction with small d is equal to 0.6 millimeter if yellow is replaced by X-rays, then pattern will be bright or dark, or pattern width will be increased like that. What will be your expectation? Your time has started. Once again, I am reading the problem. Yellow light is used in single slit diffraction with small d is equal to 0.6 mm. If yellow is replaced by X-rays, then pattern will be. What is your observation regarding the pattern? Your time starts. Yes, Vinayak, gear up. Vyapak. So Radhika answer is the dark. Still anyone? So this is the answer of Radhika. She said pattern is a dark. Then what about others? Neha, dark. Neha, I think first session for you. Am I right? Yes, still. Any more answers? It is really a conceptual question which do not require any mathematical operation. Mansi also said dark. Radhika dark, Neha dark, Mansi dark. Then what about boys? Vinayak Singh, Vyapak, what are you all doing? Give some answer. I am waiting for you. Yes, your time is up. So only 3 were responded for the answer. The answer is no diffraction is observed. There is no formation of diffraction. No question of discussion about diffraction. No diffraction will be there. This is the correct answer. Why did you give dark Radhika previously? Bhageshwar dark, wrong. Yash Pratap Singh bright, no. There is a Vinayak Singh perfectly well. There is no diffraction. In the beginning of wave optics, I have given you a very vital point regarding the dual behavior of light. I asked you at that instant one question. Who instructed a light to behave as a ray or behave as a wave? Does light possess any artificial intelligence? I put this question. It is the size of the obstacle that decides the behavior of the light. It was the reply I had given you. Once again, if you did not remember, please make a note of this point. I only gave the options means I just mentioned a hint which you will say. If option is wrong, you have to say deliberately. It is not a NEET exam. You could have given the answer, Radhika. So here the point is, for a diffraction there is a condition. The condition is that the size of the obstacle B must be in comparison with the wavelength of the light. When this condition is met, then only you can get the concept of diffraction. Here in this case, the diffraction grating has a size of 0.6 millimeter. So the size of the diffraction grating is 0.6 millimeter, implies D Here B is the size of the obstacle. Here our grading is they have given the symbol D. D is very greater than lambda. There is no question of any agreement between the grading size and wavelength of the light. Mismatch, heavy mismatch, it leads to no diffraction. This is the concept behind formation of zero diffraction. Got the clarity? Now I am proceeding to the problem number 2. Here when you observe this problem, I did not say option A, option B, option C, option D. Just I mentioned something B, D, rising arrow, falling arrow, bus. It is a conceptual question. Now I am proceeding to the question number 2. A plane wavefront. Now it is a problem comprising of calculation. Be ready, Radhika and others. A plane wavefront of lambda is equal to 6 into 10 power minus 7 meter falls on a slit of width 0.4 mm. Josna, don't worry, I am waiting for you. A convex lens of focal length f is equal to 0.8 meter placed behind slit focuses the light onto the screen. Then linear diameter of second max is dash. Option A 6 mm, option B 12 mm, option C 3 mm, option D 9 mm. Once again I am narrating the problem. A plane wavefront of lambda 6 into 10 power minus 7 meter falls on a slit of width 0.4 mm. A convex lens of focal length f is equal to 0.8 meter placed behind the slit focus the light onto the screen. Then linear diameter of the second max. Option A, option B, option C, option D. Your time starts. Waiting for the quick, more accurate reply. Yeah, Neha, get up, Josna, Ash, Radhika, Vinayak, Kunal. Hi Kunal, how are you? Get up. Apeksha and Vyapak. Waiting for the reply. Waiting for your answer. Gear up. This time totally try to overtake Radhika, who was reading the game for the last few weeks, so that Radhika already declared the answer as 6 mm. Fantastic, Radhika. Answer is 6 mm. That is the linear diameter of the second max. Second max linear diameter is equal to 6 mm. Radhika declared her answer as A. Yash declared his answer as C. Neha declared answer as A. Still I am waiting for few more options. Till all the options came, I cannot declare the answer. Radhika's answer is A. Yash answer is C. Neha A. Josna A. Still, Vyapak, where are you? Waiting for your message. Our time is up. Now the right answer is 6 mm. It is Radhika who declared first. So the correct answer is 6 mm. Now let us see solution behind this. They mentioned lambda. It is very clear. They mentioned slit width. In my notes, I give the slit width as D. D is equal to 0.4 mm. That was thing given. And I have given another formula in terms of the focal length. Focal length nearly equal to capital D. Bhageshwar has declared his answer as a B option. So still I am waiting for few more options. Until then, I will be waiting for you. Focal length is nearly equal to the distance between the screen and the slit. Here it is mentioned max. And first you have to write the condition for path difference delta x for max. That is nothing but 2n plus 1 into lambda by 2. This is the condition for getting max in diffraction, 2n plus 1 into lambda by 2. But they mentioned it is second max. Replace n by 2. Then you will get delta x is equal to 5 lambda by 2. This is delta x. But we know that delta x is equal to d sin theta. What is the delta x? Delta x is equal to d sin theta. But sin theta is equal to tan theta is equal to d into x by capital D. Call it as equation number 1, equation number 2. But just now I told capital D is nearly approximated with focal length. Then when you substitute that here, this is equal to 5 lambda by 2. This is equal to 5 into lambda by 2 will be equal to 5 lambda by 2 is equal to dx by capital D. Here what is this x? That is nothing but linear diameter of the second max. So 2x is equal to 5 lambda into f by small d. So linear diameter means when you observe the diffraction figure, this is x, this is x. So from here to here it is equal to 2x. It is a slit. So this is the geometry for the problem, and you are asked to find a diameter. Diameter means double the value 2x, 5 into lambda into f by d. By putting lambda is equal to 6 into 10 power minus 7, focal length is equal to 0.8 meter and slit width 0.4 mm. Be careful, they have given in millimeter. Final answer should be 6 mm. Anyone has doubt in the concept behind the problem or applying the concept for solving the problem, I am giving you 1 minute time. If you message me, once again I will explain this problem. If you are fine, say okay sir, so that I can proceed for the problem number 3. Linear diameter is nothing but the width of the second bright from the central multiplied by 2. This is second bright from the central, its distance is x, but diameter means you have to take that end to this end. You are asked to find 2x. Shall I proceed for the problem number 3, or anyone has a doubt in this problem? Please let me have the clarity, because understanding the concept is one phase, applying the concept for solving is the second phase. If you provide proper interface between understanding the concept and application parts, then you will be fine. Nobody can beat you in this world. So I am proceeding to the problem number 3. Suddenly I will take you to the polarization, and I would like to know the switching time of your brain, so that without discussing the polarization, now it is a time to take you to the polarization. Two Polaroids are in the path of unpolarized light of intensity I naught such that no light is emitted from the second Polaroid if a third Polaroid whose polarization axis makes an angle theta with the axis of first one is placed between these two Polaroids, then intensity of light from last Polaroid will be, once again I am narrating, already there are two Polaroids in the path of unpolarized light. The intensity of the unpolarized light is given as I naught, and these two Polaroids are placed such that no light is emitted from the second Polaroid. Now, if a third Polaroid whose polarization axis makes an angle theta with the axis of the first one is placed between these two, then the intensity of the light from the last Polaroid will be, this is a problem. Now I will see the response time of your brain, how fastly it responds to change from problem of diffraction to the problem of polarization. Yes, gear up for solving the problem. Attack. This problem, who will give the first reply? I will check. Already I have given two problems. First problem everyone has given. Second problem Radhika stood first, followed by few more, Josna, and problem 3 I will see who will give quick, accurate answer. What happened? Your time is running fast. This was a JEE advanced level problem given in Indian Institute of Space Research, Bangalore. You know, IISR exam, it is more tougher than JEE problems. JEE exam is moderate when you compare with Indian Institute of Space Research exam. So this was a model given in IISR. I am waiting for you. Your time is running out. At least declare some answer. Neha, Yash, Josna, Radhika, Bhageshwar, Vyapak, Pratap Singh. What clear? I am waiting for the answer. Are they in contact? Radhika has given some answer. I naught by 8 sine square I naught by 8 sine square 2 theta was the reply from Radhika. This was answer given by Radhika. I am waiting for other answers also. Then I will finalize the correct answer. So, as per Radhika, the answer was I naught by 8 sine square 2 theta. This is her answer. Maybe still I am waiting. Neha, Josna, get up. The time is up. I naught by 8 sine square theta is the right answer for this problem. So again, it is correct answer given by Radhika. Now see the background of the problem. Say they mentioned no light is coming out of the two polarizers. One, this is polarized 1, this is polarized 2, are arranged such that no light is coming from the second polarized. This implies, Radhika, your final answer is absolutely right. So, when you observe this light is not coming out means they are to be placed perpendicular to each other, that is called as crossed polarized catap. They are to be placed, if one is along the y axis, other should be along the x axis. If one is along the y axis, other should be along the z axis. So, if anybody do not know this, please make a note of it. For light to not to emitted from the second polaroid, it should be placed crossed way with the first polaroid. So, it is very clear that angle between P1 and P2 last polaroid is 90 degrees. Now, what they have done? They brought another third polaroid P3, third polaroid P3, whose polarization axis makes an angle with the axis of the first one. So, let us say this is polaroid number 3. Observe on the screen, it makes an angle theta with the polaroid axis of the first one. So, this is the geometry of the given problem. Now, this is P1, the central one is P3 and extreme right one is P2. Now, output of the P1, they mentioned intensity of the unpolarized light is I naught. Please, everyone should follow clearly, boss. You are supposed to handle typical brain mind blowing problems. So, I naught is the unpolarized light and the light coming out of the P1 is half of the intensity, which is equal to I naught by 2, that is the light coming out of the first polaroid. This intensity I naught by 2 will be the input to the P3. Now, between P1 and P3, you are supposed to apply law of Malus. So, according to law of Malus, the output of P3 is equal to input into cos square theta. Input is I naught by 2 and angle is equal to cos square theta. The angle between the two axes is given as this one. So, I naught by 2 cos square theta will be the input to the polaroid P2. So, I call this I naught by 2 cos square theta symbolically equal to I1. So, what is I1? I1 is the output intensity from P3 central polaroid. Now, this I1 is given to P2 as input. Again, here you are supposed to apply law of Malus. So, output of P2 is equal to input I1 into cos square angle between P3 and P2 90 minus theta. I1 cos square 90 minus theta. Here I mentioned 3 steps with blue color. Did everyone understand all the 3 steps? If you have any doubt, please message me so that once again I will clear your conceptual blocks. So, unpolarized light intensity mentioned in the problem I0. From the first Polaroid, it will be I0 by 2. It is given to the central Polaroid where the angle is mentioned as theta. Then output of the central Polaroid is equal to I0 by 2 cos square theta. I call it as I1. This I1 is input to the extreme Polaroid P2. So, output of P2, apply law of malice, I1 cos square theta into 90 minus cos square 90 minus theta, that is equal to I0 by 2 cos square theta. I1 value is I0 by 2 cos square theta multiplied by sin square theta. This is whatever the line I put, that is the value of I1, I1 sin square theta. That is nothing but, when you observe this, I0 by 2, I multiply 4 numerator and denominator, 4 sin square theta cos square theta by 4. This is equal to I0 by 8. 4 sin square theta cos square theta is equal to sin 2 theta whole square. This is the final answer. I hope everyone has understood easily. I have given the geometry. This is the geometry. I1 and P1 and P2 are arranged in crossed way. How do we know? It is a concept. What is that concept? When two Polaroids are arranged perpendicular to each other, no question of light coming out of the last Polaroid. In between, I placed the third Polaroid such that it makes an angle theta with the previous one. So, by applying the law of malice, you will be able to get the things. Next, I am proceeding to the next problem. Are you ready? So, I think everyone has understood the previous one. Now, as we all knew, light is an electromagnetic wave. Light has briefing of the coming problem. Light has both electrical field vector, magnetic field vector. Electrical field, magnetic field are perpendicular to each other. They are not only perpendicular to each other, but also perpendicular to the direction of propagation. So, electrical field vector we designate with E bar, magnetic field vector we designate with B bar, and the direction of propagation, all three must be mutually perpendicular. This is a briefing for the coming problem. Now, x axis, y axis, z axis, electrical field vector E bar. Now I am giving the problem. The figure shows electromagnetic wave at certain point and certain instant. Wave is transporting energy along negative z direction, then the direction of B bar of the wave at that point and instant. Option A towards positive x-axis, option B towards negative x-axis, option C towards plus z direction, option D towards minus z direction. Now your time starts. Yes, Apeksha, Mansi, Vera Vikram Pratap Singh, Vyapak, respond boss, respond. Apeksha said, yeah, fantastic Apeksha, super. The answer is yeah, Apeksha is no. Gearing for lock horn with Radhika. Mansi said B. Still I am waiting for options before I declare the correct option. Apeksha came very fastly and declared some option A, followed by Mansi with B. Still awaiting. Still awaiting. Your time is up. The answer is positive x-axis along plus I cap. Apeksha really super boss. Fantastic. So Radhika A, Josna A. That is the correct answer. A is the right option. Now let us see the background behind this problem. When you take an electromagnetic wave, electrical field vector, magnetic field vector, direction of the propagation must be mutually perpendicular. Here in this they mentioned it is moving along negative z axis. Shailendra, sir, it's taking too much time to write questions. Fantastic. So at least you answer some question. You are taking too much time in writing in the notes. Okay, Shailendra, I will give good amount of time to declare the answer, don't worry. So now onwards I will slightly give few more seconds as our friend Shailendra expressed, so that yeah, next week onwards I will give the typed questions. But till now I did not find you giving any answer, boss. You are always writing the questions only, no? You say something for any of the questions. So when you observe this question, the answer is positive x-axis, because the direction of the electromagnetic wave is decided by cross product E bar cross B bar. This is the key point. Make a note of this. The direction of electromagnetic wave is given by cross product of E bar and B bar. It is already mentioned the wave is propagating along negative z direction, means minus k cap. So E bar, don't worry Shailendra, I consider your appeal. Next session onwards, okay, don't worry Shailendra, I am for you. I will definitely provide you. Next week onwards, I will give the typed questions so that I can give more number of numericals. Fantastic, Shailendra, keep it up. But try to give some answers also, no, in between whenever you are in online. So mentioned E bar cross B bar is equal to minus K cap, and in the figure they mentioned E bar along positive y axis, that is nothing but J cap. So E bar is along J cap, then what should be the direction of B bar to get minus K cap? We know that I cap cross J cap is equal to K cap. If you reverse it, then J cap cross I cap is equal to minus K cap. Already E bar is J cap. Then to get that, the direction of B bar is nothing but I cap. So J bar cross J cap cross I cap is equal to minus K cap. So the direction of this is along positive x axis. Now it is the time of contest question. If M is a magnetic moment, B is a magnetic field, then the torque tau bar is defined as cross product of M bar cross B bar. And the winner of this, Indrajit, give him a big clap. He got one atom session free. Keep it up, Indrajit. Fantastic, fantastic performance. So Radhika, this is a contest question, and our contest question for this week in YDSG, please make a note of the problem very fastly. 60 fringes, like our Sailendra asked like this. Definitely Sailendra, definitely I am your friend, don't worry now. In YDSG, 60 fringes in the field of view of monochromatic lambda 4000 angstroms for light of lambda, here put a comma, for light of lambda 6000 angstroms, 6000 angstroms, then the number of fringes in the same field of view. This is the question in YDSE. 60 fringes in the field of view of monochromatic light of lambda 1 4000 for a light of lambda 2 6000, number of fringes in the field of view. This is the question. So along with this, I have given the best set of questions and try to crack them, and I have given combination of interference, diffraction, polarization. So focus all those 10 questions who are in the band and try to crack them. So the passport batch is there. So who are in the passport, open them and solve them, so that there are very good problems. So your knowledge level will be improved, conceptual level will be improved, and numerical part will be improved. So gear up for those 10 questions. Thank you for joining. Have a nice day. Bye friends.